This video is going to just explain a little bit about Chebyshev's rule, which is found in section 9.4 as an application for standard deviation values. The benefit of this rule is that it can work with any type of distribution. It could be skewed, it could be bimodal, it could be symmetric. And what it provides us is with an idea of how much of your data can fall within certain values if you know the mean and the standard deviation. The rule is found on page 683 of your textbook, and it states that at least 1 minus 1 over k squared of the scores fall within k standard deviations of the mean. And we obviously are not going to let k equal 1 because then you would get 0 out of this calculation. And we know that you're going to have some numbers that fall within 1 standard deviation of the mean, but this rule does not address that particular situation. So if we were to let k equal a 2 in this formula, we would have 1 minus 1 over 2 to the second power, which would be 1 minus 1/4, which is 3/4, which we know is 0.75, or even as a percent, 75%. So what this rule would say is that at least 75% of all the data, so of the scores that you've collected, will fall within 2 standard deviations, because k was a 2, of the mean, which is pretty generic at this point. So what we can do is bring in an example. And in your book, their example is about the Batmobile. They say the lifespan of the Batmobile has a mean lifespan of 9 years and a standard deviation of 2 years. So if we bring that information down into this problem, we could bring in 9 as the mean. And to be within 2 standard deviations means that you're going to add and subtract 2 of your standard deviation distances. And our standard deviation happens to be 2 years. So we're going to take 9 and we're going to add and subtract 4 years to that, and we will get the following results. If we perform our subtraction, we'd have 9 minus 4, which is going to give us 5 years. And if we take 9 plus 4 to get our addition value, that's going to bring us up to 13 years. And so we can take those dates and put them into this statement and say, at least 75% of Batmobiles have a lifespan between, and we bring in our numbers, 5 years and 13 years. And that's Chebyshev's rule. You can actually put in other values. You can put in decimals, other whole numbers. You could put in a 3 if you wanted to see what percentage of Batmobiles are within 3 standard deviations of the mean. And so to be within so many standard deviations of a mean is that you're taking the mean value given and you're taking it times however many standard deviations they're talking, or adding and subtracting it with however many standard deviations they are talking about within that part of the rule, and you're bringing in that standard deviation value that's part of your given event.